Okay, so now we can share the screen. Share. Okay, good. All right, so yeah, let's get started. This should be familiar to you by now. So we're going to navigate to the terminal. So desktop, clear ls-l, cd, ITS 350, clear. All right, so substitution cipher, this is going to be XOR. Okay, so I'm going to create a new directory. I'm just going to call it XOR Python. Okay, so that we can play with the operation. Okay, so there we go. And then let's cd into that folder. So we have a clean folder. All right, so we got nothing here. Okay, and we're ready, right? So we're ready. So how did XOR work? XOR, what was the truth table for that? 0, 0 is 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Okay, so the symbol for that in Python is going to be something called a caret. Okay, but this applies like at a binary level. And so what we need to do sometimes is we may have a string or numbers, etc. We have to convert those into what is called a byte array. And then once we do that, we basically have our zeros and ones, and then we can apply caret to zeros and ones and perform the XOR operation. Do you guys see that? Yeah. All right, so let's bring up the Python interpreter first, just to take a look. So that's the Python interpreter. So what we're saying is, if caret is this symbol, okay? So it's usually like key number 6 in your keyboard. And so if you do 0 caret 0, gives you 0. Okay. If you do 1 caret 1, gives you 0. If you do 1 caret 0, gives you 1. And if you do 0 caret 1, should also give you 1. So you can see that there. That is basically XORing, zeros and ones in Python, in the Python interpreter. Okay, so that's the basic idea. Okay. Now you could also try to play with like XORing something like this, right? And it doesn't like that one. Leading zeros and integer literals are not permitted. Use a 0 prefix to octal. Okay, so is that a 0 and an O? Is that what you guys see? If it takes it. 521. So I think it gave us the what's it giving us? It may not be a good way of doing that. Let's see. Let's try byte array. And then here, okay, so that's also, oh yeah, so this is giving me a byte array of size 256, I think. So that's probably not a good approach. Let's try byte array of 8. Okay, so it gives me 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's do byte array of random of let's do from OS import random. So this is a function to get a random number. All right, then let's do length equal 8. Usually the key sizes, right? So let's do that. So length is now 8, right? Then let's try random of size length. Okay, so that gives me 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. And then this might be easier, and let's write the script instead. Okay. So let's think about the logic that we're going to have. All right, so I'm going to do ls-l nano. Let's call this XOR.py or XOR example.py. Okay, so the challenges, as you will see, are these things, right? So the byte array is going to be tricky because we have to convert strings and things into a binary level. And then we have to correctly apply the XOR operation. Okay, those are the two challenges. If we master that, we'll be in good shape. Okay, so we'll have to remember a couple of things. So let's start with that library. So from OS, import random. Okay, so that's definitely something that we're going to need. We're going to have to define the length, which is basically going to be equivalent to the block size. Okay, the things that we're going to need are a message. So let's say let's actually go down here, add a comment like the main section here. Okay. And let's do main. Okay, so the first thing is going to be the plain text, which is going to be equal to some text. So let's say this is a top secret. Okay, so this is what we want to be able. We need to go from this, the byte array, to be able to perform an XOR operation with a key, and produce an encrypted version of it. Okay, so we have that message. Let's go ahead and print it. So that's going to be plain text. Okay, let's do Control X, Y. This should run. Okay, so this is a top secret, works fine. All right, now the next step is going to be, we're going to generate a key, okay? So generate key. Okay, and we're going to define a function for this. We're going to call it gen key, basically. Okay, now gen key is going to be, to keep things simple, And so there's, well, for now, to keep things simple, we're just going to make the key the same size as plain text. That just makes it super easy. But if the algorithm we're trying to implement would need to be a block type of an approach, right? So let's just start with this approach. So to do that, let's do length, right? And that's going to be equal to len of plain text, right? And that should give us basically the length of plain text. And now that can be the input to gen key. Length, like, oops, like that. So now we have to go ahead and obviously define this function. Okay. So define gen key. Okay. So we're going to define it. This is, we can call this length still. 1, 2, 3, 4. So let's just add a message here to indicate generate or generating the key. Okay. Everyone with me so far? All right. So here, this is where I'm trying to think. It's doing some kind of an implicit conversion, this thing. That's why I wasn't able to see the zeros and ones. But, can't remember. So basically the function should simply return a byte array. And we're gonna maybe have to look up like the definition of this so that we can zero in. And a byte array, so the thing that happens is this, okay? At a very low level, Python really is almost like an interface to C++. That's really what it is. So it only stores the data in one specific type, which is the very binary low-level type. But whenever you do something like use it in variables and things, it might represent it as a hex or the binary or the string, etc., right? But everything is being stored in that low-level data type. Okay, especially when we're saying, and now when we're saying this byte array, you know, we're specifically making the data look like that. But when I'm printing it, it may not be printing exactly like that. So I have to do something to make it look like what I want. And I'm forgetting what it is that I need to put. I think I need to put, if I remember correctly, it's like B like that. So tell it that it's binary, okay, to the data. So we'll figure it out. All right, so we have here urandom is just a function. So remember in cryptography, we use a lot of like pseudo-random functions to try to generate data. So in this case, urandom should give us a string basically of that specific size. That is the input then that we give to byte array so that it gives us that byte array of that specific size. Okay. So this is the random sequence of this length, and then just convert it to byte array where we're going to do the operations. So let's go ahead. That should be the whole function, and that should work for generating the key. So now let's just see what it generates. So let's do print key. Okay, and now we're going to run the code. So I'm going to run it. And as you can see, it's giving me that. It's saying that it's a byte array. And it's basically of the size of the string, should be. Okay, so that's the key. Okay, now let's go ahead. Once we have the key, let's try to print it in another format. So the only thing that comes to mind right now is to make it a string, for instance. So I'm going to say key string. And then we have a typecasting function string, right? And that should be key. And so now I'm going to print key string as well. key string as well. So it's Control X, Y. Okay. It literally, I think, just converted it to a string. Let me take a look at something. All right. So now, well, we're going to assume it's correct, right? We're going to assume it's got the right length. Printing as a string did not change anything. Trying to see. Let's just see what happens if I do this. Just curious. Int doesn't like it. Byte maybe. It doesn't like that either. Let's see how to view a byte array. All right, so all right, we're gonna have to work with it as hex until I can figure out how to convert it to zeros and ones. I mean, it should work, but I just wanted to see the zeros and ones. I don't know the exact conversion for it. All right, so it should still work. All right, so let's complete the script and then we'll come back to that. Okay, so let's go back. So let's remove this part here for now. And we know so far this works, right? So we have the key, we've generated the key. Okay, and we know the key is the same length as the message, so we're fine. Okay, we shouldn't have to worry about alignment. All right, so given the key, the next step is to encrypt, right? So that's pretty much what we did before. So let's call this cipher. Let's call this encrypt. So we're going to define the function encrypt. This will take, for encryption, we'll take the plain text message, which we will have to do something to it. And it'll take the key, of course. Okay. So now this is also not a lot of code. It's just, we just have to get it right. Okay. And because we're not working with strings, but at a byte array level, it's a little bit more challenging. All right. So I'm going to go down here and let's add the function encrypt. So define encrypt colon. So this takes, let's just call it plain, comma, key. All right, so now 1, 2, 3, 4. So to perform this encryption, we will need to they should have the same size, right? So if they have the same size, we can do what is called a list comprehension. So let's do return. And then we're going to say for I in range, so that's the index, right? Of the size of plain. So we're going to say length here of plain. Right? So that should be the size of the message, right? And now we are going to, like we did before, iterate through every character. So that gives us in a list comprehension, you don't do the stuff below the 4, you do it before. So then the value would be here. So the index I would be there, right? And now we just need to use it. So we need to, since they're both the same size, we would extract basically the first element from the key and the first element from the message and XOR those. Then the second element from the key, the second element from the message and XOR those, and so on. Does that make sense? So that will be the approach, basically. All right. So to do that, we need plain, right? And we also need key. And the index is how we kind of link them, right? So the index then can be shared by, having it here and having it here. And the operation that we're performing is an XOR between that first element of the key and that first letter, let's say, of the message, and then for the second one and for the third. So the symbol here should be caret. You guys see that? That's the symbol. Now, because the message is a letter, we need to convert that into the equivalent ASCII, and we saw how to do that on Tuesday, right? So we use ORD, and that should be it. Okay, so after that, if we perform this operation, and I think we have to do one more thing, which is to add a B here. This is what I was talking about. So there's to indicate that when we pass this over, this needs to change a little bit. Okay, so that's the other part. So when we perform or it might just work like that. All right, so let's try it without the B. All right, so let's go ahead and do this. And let's return here also a byte array. So let's convert this list comprehension into a byte array. Open parentheses, close parentheses. This returns the XOR operation of the letters and the keys, okay, which is in cipher, and now we can print cipher. So if everything worked, so as you can see, it's not that much code. We just really have to get this right. Okay, so let's try this one, see if it gives us an error, and then we can debug it if it does. Okay, so no error, right? And it looks different from the original one. So it may have performed the operation, right, correctly. How do we know if it did it correctly? What's the only way that we could test it? Decrypt it, right? If it decrypts to the original message, this is a top secret, then hopefully it worked. You see that? So this is basically the approach, okay? Now the nice thing about this is that you're not going to have to change this operation. It's always going to be the same one. What may have to change is the algorithm, the steps that you take, but in essence, the operation of XORing should always be kind of the same one. So now let's go back to the code and let's try to decrypt it, right? Which is going to be the way that we're going to know if it works or not. So I'm going to basically, now that I have a cipher text, I'm going to try to decrypt it, right? I'm going to create a new function, call this one plain decrypted. Okay, and so this is going to be decrypt. So decrypt. All right, and then now we have to think, what are the inputs to this function? So what are the inputs? The arguments to this function, what are they?
Cipher and key.
Yep. Cipher and key. Remember, this is a symmetric approach, and we're not concerned about who has the key or anything like that. So we just have cipher and key, right? And then when it's done, we're going to print it out, plain decrypted. Okay, so we need to define the function decrypt. All right, so let's go ahead, do the same. So again, we have to think carefully here. This one takes cipher and the key. They're both should be the same size. Okay, then 1, 2, 3, 4. Okay, so now we're going to take a similar approach, right? So let's do the same idea. Return list comprehension, right? Okay, and then this list comprehension Okay, so for I in range of length of ciphertext, so length of ciphertext, same idea in theory, right? Or cipher, sorry. Same idea. We're gonna find out how many characters we have in cipher, and we can index through them. So now over here, that's where the I goes, and then we're gonna use that I again to link the cipher with the key and perform the caret operation character by character, except that we're doing it at the binary level, right? So in hex, basically, and that's why it's difficult to read. So let's do, so it should be, what do you guys think this should be? So there's a caret operation, right? So what do you think? Yeah, right. So same idea as before. Now before there was one issue, and that was the ORD, right? So maybe we have to use that CHR in this example. We need to look at that, but it's possible that we do need to do that. Okay, so there's a lot of data type conversions going on here. So let's do, this part should be like this though. Cipher, caret, and then key, like that. Okay, that should be it. Let's just try it like that. I'm just curious what happens. Decrypt is not defined. Oh, maybe it's the uppercase. Okay, let's try it again. Okay, something that makes sense. At least it's not XOR, so I can work with that. What do you guys think? 116, 104, 105. Let's do some cryptanalytics here. Oh yeah, please. CHR, right? So if you do cryptanalytics here, what do you notice? Like, yeah, the ASCII table, right? And these are like numbers. So this is a top secret, right? The most common letter is which one? It's got 3 T's, right? At the beginning, in the middle, and at the end. The beginning number is 116. This one is 116. There's got to be a 116 in the middle. You guys see that? There's a pattern there. And it's, again, remember that makes it insecure, but we have basically this. So now, how would we convert them into letters? Let's go ahead and go back to decrypt. We did CHR, and that's kind of very consistent with what we did on Tuesday, except that we're using, now that value is the result of this XOR, right? So we can literally just wrap CHR around this, and it should get those numbers and convert them to the ASCII letter, hopefully. So let's go ahead and try it out. Clear here. Okay, so if I run the script, okay, this is a top secret. So did it work? It does, right? So it's nice because we made it the same length. I'm sure we can make this into the binary. I just don't know the command for it. I don't remember. But I'm sure there's something. I'd have to look it up, and I couldn't find it. All right. Yeah, so that's basically it as far as the example, right? So the bit of a challenge, right, in the code. This is on the GitHub. Now, what I want you guys to do with the homework is you're going to use this code to implement an algorithm. Okay, a simple algorithm of integrity, basically, which is like a type of a hashing function. So I will describe the algorithm, and then we can discuss ways of approaching it, okay? And we'll do several problems like this throughout the semester, always going back to this XOR operation. We will actually, we will get as far as trying to implement some parts of DES, which even though DES is no longer secure, it's still, you know, it was very popular for a very long time. And, you know, it's something that you could implement if you wanted to. All right. So anyway, that kind of concludes this example. All right. And as you can see, we have gone, I can go over the code again. You know, we created the library, we created 3 functions: generate key, encrypt, and decrypt. The key is, or the key issue is that in this case, I made the length of the key equal to the length of the message. So that made my life a lot easier. What you will need to do going forward is, instead of doing that, you will have to define what? A block. Do you see that? And so once you've defined a block, let's say that you make it 8 bits or 16 bits, you need to take your strings, right, and break them up into like 8 letters or 16 letters as a string, manipulated at that level. And then once you've done that, then you should be able to use the same code, because it's like, let's say that this was, what I'm trying to say is, imagine this says this is a top secret, and here, you know, and there's a whole bunch of paragraphs, right? You would define that you want this block to be of size 16, so you would take the whole string and break it up into all the different blocks of size 16. Where for the last one, you would do padding, okay? So it's also 16, because remember, if you don't add that padding, it's not going to work if they're not both the same size. Got it? Yeah. Do you guys understand what I'm saying? All right. So that's the kind of the explanation, right? So we have gen key, encrypt, decrypt. We started with a message. We created a key of the same length. We ran both in the encrypt, and we basically performed a XOR operation using the caret symbol over here. Okay, and we used some type conversions, and then after that, we printed the cipher. Then we feed the cipher and the key into the decrypt function. And again, in the decrypt function, we take cipher and key, perform an XOR operation, and basically we got the numbers that we converted to with the ASCII function into the letters themselves. Okay, so let's go ahead and run it one last time. And you can see it basically gives us the list. After this, as long as you can read it, it's fine. Obviously from here, it's a list, so you could just like make it into a single string. There should be, let me actually do that. I think there's a command in Python to do that. Should be, what is that command? I think it's something like this. Dot join, I want to say. And then it would be plain encrypted. Right, so you can see it went from a list now to a string. So this is actually a string there. So I did it with a space, I think, in between. I can remove that space and it'll look more presentable. So if I do this here, and you can see now you've got basically a nice readable message. Okay, any questions? All right, so let me stop sharing here. I'm gonna stop.